How many of you still read real books? Oh. Obviously, a room full of intelligent people. So you might have guessed I love real books as well. And when Yarn said she's always talking about something new, it's because I've read a new book. And when I finished with it, if it's a book I really loved, I look for the next opportunity to give it away. So this is a talk about noise, and the book is Noise by Daniel Kahneman, and I want somebody to have that. I'm also going to mention along the way another book by Daniel Kahneman, and I'm not going to talk about it today, but I think everyone should read it. It's called Thinking Fast and Slow. How many of you have already read it? Okay, so there must be somebody out there who loves real books, who hasn't read it. Yes, thank you. Thank you. All right. I love it. 2 women got the books. Yay! Woo! Thank you so much. So we're going to talk about noise. This first slide I think is interesting. It has my contact information. If you don't get a chance to ask a question today, then I'll be here tomorrow and the next day, or send me some email. You might not think of a question until tomorrow. What Kahneman says, you need to turn all of your problems and worries over to System 1, sleep on it. It won't be until tomorrow morning that you think of a question. So I'll be here tomorrow and we can talk, or send me some email. So how do you think? How do you make decisions? In general, we go through a process that, well, this isn't linear. We don't necessarily follow a series of steps when we make an important decision of some sort. I don't know about you, but I wouldn't do this for gelato. One of the things I missed when COVID hit and we all had to stay at home was traveling. And in Italy, I found my decision-making challenge, gelato. Miles and miles and miles of gelato. And I tried to overcome it by going through a decision-making process, and I finally realized it's better just pick one. And for a lot of decisions, that's good advice. I recommend it. But for things that are a little more complicated, well, we tend to do a little bit of this kind of thing. We want some information, some data. So we spend a little bit of time on research. And then we, do some analysis or a calculation, a prioritization. Looking at the pluses, the minuses, the percentages, evaluating that data. And then we even listen to our gut, our System 1, and then we reach some kind of conclusion, a decision. Should I marry this person or not? Should I take this job or not? Should I go to the GOTO conference in Chicago or not? Now that process has a name. In psychology, it's called clinical judgment. And as Jorn mentioned, I'm really concerned about science, especially since we don't talk about it much. I won't ask you, how many talks did you hear today? How many of them mentioned scientific evidence? How many of them mentioned experimental evidence involving randomized, controlled, double-blind? I mean, we're concerned about that for vaccines. We don't seem to be concerned about that for the way we work. So there's little science in our decision making. So we should look to the areas that do science. We should pay attention to people who are studying the kinds of things we do, and that includes thinking and decision making. So this process has been studied. Wouldn't you like to know whether it works or not? Hello? Hello? Yes, okay, thank you. Typically, we could do our own experiments. We could do our own experiments not only for decision making, but for anything else, but we don't. We operate on the assumption that we are smart people. Well, we already know that, right? Because you read real books. We know you're smart. And so therefore, intuitively, your approach to just about anything should be good. And that includes decision making. But you have no evidence. You don't do any randomized, controlled experiments. So how do you really know whether you can depend upon that process or not? We don't do that. We don't examine our results. And unfortunately, even if we did, every now and then I know that people look at software estimation. How good is your software estimation process? And every now and then we compare the actual with the estimated. And if there's a discrepancy, what do? We rationalize, we explain it away. We say, well, our estimate was off, but because, and now we'll come up with a reason. That's the rationalization part. We'll come up with a reason why that estimate was not right on. And we won't learn anything. Now, that's not just you or me. That's how people operate. So even if we took the time to do the experiment, likely we wouldn't learn. So we need to call upon the scientists who do the research and say, well, how about this process for making decisions? Is it any good? Remember, it was called clinical judgment. Well, when you look at all of those studies from the psychologists, how is it? So here's the bad news. Research shows that you would really be ahead if you just flipped a coin. 50-50. And your decisions would be as good. So I have just saved you an enormous amount of time. Instead of gathering the data, instead of examining and doing some sort of calculation or analysis, just flip a coin and the decision will be as good. Do you believe me? Let's go back to 1954. Oh no, 1954. How many of you were alive in 1954? Just my husband and me. We were the only two people. Nobody else was around, Carl. Good Lord. 1954, that's prehistoric for these people. They can't even imagine what it was like. Do you want to know how old I was in 1954? We're going to look at some research that was done in 1954, long before you were born, when I was 12. Oh my God, she was 12 in 1954. It was done by an interesting guy named Paul Meehl at the University of Minnesota, and he looked at that clinical process, that judgment, that decision-making. He actually studied it. And he concluded that it really wasn't very good. that most of the time, flipping a coin or coming up with what you could call it a little model, some kind of simple, very simple model was better than spending a lot of time gathering data, doing analysis, trusting your gut, reaching a conclusion that human decision-making was flawed. It doesn't lead us in a good direction. Now, wait a minute, that was 1954. We're still using that process. Why didn't we all get really excited and say, wow, our decision-making process isn't working, so we should do something about it? Why didn't that happen? Nobody. Yeah, well, there is that. Because we didn't like it. Nobody liked that result. Would that make a difference? Would that make a difference to scientists? To the rest of us who are hearing scientific results? If we don't like the result, what will we do about that result then? We will ignore it. We will raise various fingers in the direction of those scientists and say, hey, I'm not following that. Nothing happened. It wasn't until, how about 2000? How many of you were alive in 2000? Oh, well, okay. A lot can go on in 50 years. We can see that. 50 years later, 50 years, another massive study of that process that, we go through to make decisions, and said, not only is it flawed, but we now have done some cost-benefit analysis. And we find that using some kind of simple model is not only better, but it's cheaper, more efficient. And in the face of that, what do you suppose people did? Did they get all excited and say, oh my gosh, here's even more information, more scientific information that tells us our process is bad? No, sorry. It still didn't happen. We still ignored it. We still continued thinking, making decisions in the same way. And then later, I know most of you were alive in 1968, so this was an interesting experiment that finally got our attention. It had to do with diagnosing cancer. It was done at the Oregon Research Institute. And they gathered a bunch of experts who would have been physicians, especially trained to look at x-rays of ulcers. And their determination was going to be pretty important because it was going to be cancer or not. Now, if you're on the receiving end of that kind of information, you care. That's important. So the scientists began by saying, I wonder, based on all the research, whether we could create a simple model. So let's begin. Let's gather the researchers, the experts, and we will have them give us, well, what do you think are the 7 most important things? 7 variables that you would look at. One might be the size of the ulcer. One might be whether it has a regular shape or not. So they came up with 7 ABCD, 7 things. And so they said, all right, we're going to begin with a very simple model. It's simply going to be A plus B plus C and so on. And then they said, now let's test it. So they found 96 cases of x-rays of ulcers. And they gave them to the experts with the idea that, well, the experts would know. The experts would be able to make the decision. And we will compare our simple model and we will improve. We'll get better. They thought initially that this simple model certainly couldn't do a good job, regardless of what the research showed. So the experiment involved 96 cases. And they did something that's kind of sneaky. They would show a given doctor a particular x-ray and ask for a diagnosis. And then, unbeknownst to the doctor, later on in the experiment, show that doctor the same x-ray. Now, wouldn't you think? This is an x-ray. This is an expert on diagnosing expert. And now he or she is seeing the same x-ray. Wouldn't you think that the result would be the same? This is life or death. This is a serious result. Isn't that what you would expect?
Yes.
Yeah. Well, and of course you know that since I'm asking you that, that's not what happened, right? Yeah, they found that not only do the experts disagree among themselves, but the experts disagree with themselves. No doctor was consistent. And they found that this very simple algorithm, the one they thought was, well, a beginning, a starting point, that the algorithm was better, on average, than the doctors, and in fact, was better than the best diagnostician, and was consistent. Gave the same diagnosis for the same x-ray. I don't know about you, but if you've ever had a situation like that where you're waiting to hear, is this malignant or not? Is this cancer or not? A lot rests on that. You care. This is an important decision. This is not to be taken lightly. And you trust your doctor, do you not? You trust the expert, do you not? Trusting that the expert knows whatever it is, the cancer diagnosis or any other important decision, you trust that expert. And if someone were to suggest to you, hey, we've got this little algorithm, it's A plus B plus C plus, would you rather have the algorithm tell you whether you have cancer or not? Or would you rather have an expert? Somebody who's got a college degree, has been to medical school, internship, residency, lots of experience. Who would you trust? Right now, the algorithm. So, the results showed clearly the algorithm was better. Now, this is not to say that the doctors are stupid. This is not to say the doctors don't know what they're talking about. Remember, the algorithm came from the doctors. This is not to say that the doctors had some sort of simplistic way of deciding that could be captured in a very simple algorithm. That's not what we're saying. We're saying that the decision-making process that the doctors used was not good enough and could be improved upon by something very, very, very simple. Now, if that's true for cancer diagnosis, now people began to pay attention and thought, what else? What else is at stake? And in looking at the different diagnoses from the doctors. They did not agree. Often, if you're waiting for a decision like that, someone will tell you, get a second opinion. Well, now this looks like you should have a third opinion and a fourth opinion and a fifth opinion and a sixth. And maybe there's an algorithm that can capture all of that. This was horrifying. The researchers themselves said they were horrified that this little simple algorithm that they had sort of made up with the idea that, well, this is just a start, that now they see it's better. It's better than the experts. This is a quote from Daniel Kahneman in Thinking Fast and Slow, which I'm glad somebody else is going to read, who said, it's amazing, the success that can be had. There was no data. We didn't do big data analysis. There was no high-powered statistics. This was a simple algorithm where we just said, let's let all the coefficients be +1. Well, let's just put together a bunch of stuff that we got from experts who said, well, these are things that we looked at. That's all it was. Since that time, this same kind of experiment has been run for lots of different domains, not just cancer analysis. And in every case, the simple algorithm, just as Paul Meehl predicted in 1954, the simple, small algorithm was better and outperformed the experts. Now, I know everybody's concerned about artificial intelligence and generative artificial intelligence. That is not what we are talking about here. This is different. We know that those generative AI programs are fed tons and tons of data. And that after a while, they do things that we don't understand. They make decisions based on patterns that they have recognized over thousands and thousands and thousands of trials with feedback. That's not what this is. This is a simple, obvious, transparent. You could explain this algorithm to any patient. You can say, we are going to look at these 7 things. And the patient, as well as the doctors who originated those 7 things, everyone could understand it. It's not that this is some hidden, hard to understand, complex, black box approach. This is just a very simple, straightforward way of saying A plus B plus C plus D, and it does a better job at just about anything you want to name than the experts. And the reason for that is called noise. Wow, how many slides does it take me to get to a definition of what in the world? Because people have been asking me that all day. What is it? What's noise? And they thought, oh, is it the noise from the ambient environment? Is it? And I said, okay, so here's what it is. It's the randomness in that decision-making process that is there because we are human. And we bring to the table all of the things in our lives that impact every decision we make. So whether or not you had enough sleep last night, whether you had a fight with your significant other over the breakfast table this morning, whether your child brought home straight A's on his or her report card or is failing geometry, whether or not your favorite sports team won some significant game over the weekend, whether it's your birthday, all of those things make you not so good. Whereas an algorithm doesn't have to worry about sleep. It doesn't fight with his or her spouses. Is an algorithm his or her? I'm not sure. Doesn't have to worry about supporting the local sports team or not. The algorithm doesn't have any of that. What's it called? Noise. No noise in the algorithm. People are noisy. They are noisy decision makers. And worse, there's no way to get rid of it. Well, that's the end of the talk. So long, folks. Thanks for stopping by. And it is a problem. And we are stuck with it. But hope, there are a couple of things we can do, and this is one of them. The evidence is clear. A simple algorithm for something that you do repeatedly can do a better job than you can. And there are even now studies that show, well, what should that algorithm look like? How many variables should it contain? And what should the coefficients look like? So here's a list of instructions. And by the way, I forgot to say in the beginning, if you'd like to have a copy of this talk, there's no copyright on any of the slides. I'll be happy to send it to you. You can see that these are very boring slides. If you wanted a really interesting slide presentation, you should have heard Fabio today, because he was amazing. So these are boring. You can take the same text and you can make it really cool and interesting and translate it into a million languages, and it's perfectly okay with me. So here's the algorithm for creating algorithms. And you'll have that later, you can look at it. Now the problem is immediately, and people say this about the generative AI problems we're having right now, and they say, but wait, isn't that algorithm biased? Do you know what I'm talking about? Hello? That, you're not sure. You're not sure. We're saying people are biased. We know they're noisy. People are also biased. For instance, in certain parts of the world, there's a bias against people of a certain race, people of a certain religion. Unfortunately, people of a certain sex, people of a certain age, people who are born and raised in a certain country. So we have biases, and it's also impossible for us to overcome those biases. And when we create anything, including a very simple algorithm, yes, that algorithm will reflect our biases. Yes, it does. But what have we got now? We have people who are biased and noisy making those decisions. We're asking the wrong question. Instead of expecting perfect algorithms that are not biased, we should say, we have people who are extremely biased, and they're the ones who are making the decisions now. And at least from where I sit, I think that spells big trouble. So this is not bias. It's noise. So this is Kahneman's definition. Bias is predictable. If I have a bias against certain people because they're old, and unfortunately that's a uniform bias. Nobody likes old people. It's okay. I'm all right with it. Anyway, we know it exists, but it's consistent. It's always the same. Noise, however, you could be having a good day or a bad day. You had a fight with your spouse, or maybe it was another encounter with your spouse that got your day off to a better start. Maybe your child got straight A's or an F. So noise is not consistent. It's variable. It's random. So here's a picture of the difference between bias and noise. So the target on the extreme left, that's the goal. If we have 4 shots at the target and we make it every time, well, those 4 shots, those are accurate. They are not biased and they are not noisy. That's what we want, accuracy. The next one, that's noise. Those 4 shots are all over the place, random. The 4 shots in the third one, those are biased. They're not on target, but they are all grouped together. That bias always affects our decisions in the same way. And then, of course, it's possible to be like the last target, noisy and biased. In fact, that's what we face. We live with decisions that are noisy and biased. Now, the focus up to this point has been on bias. Kahneman's book and a lot of other attention has been paid to confirmation bias. So this is an example of bias and noise. Have you ever had one of those bathroom scales where you step on it in the morning and you didn't like the result? And you knew that if you, okay, let me try that again. And you just kind of moved around a little bit and maybe you tapped it with a toe and then you got on it sideways. The result was better. You ever had one of those? And after a while you knew where to stand and just how to kind of move your feet around. So that scale is biased and noisy. Random. You don't know whether it's certainly not accurate. So in the book Noise, Kahneman says everybody's been paying attention to bias. Most companies I know now even have some kind of bias training so that people know that, all right, there's confirmation bias, there's there are over 100 identified biases. And the problem is, all the training does nothing. It doesn't change us at all. He said there's absolutely nothing you can do about bias. Whereas noise, there is something we can do about noise. And that's what this book is about. Once you reduce noise, your decisions will be better, even if the bias is still there. So we see it everywhere. Experts contradict themselves. Software developers have been studied. Estimations, look at that. Estimates differed by 71%. Wow, talk about noise. The one that was disturbing to me for some reason is I thought fingerprints were pretty serious things. They could identify an individual. This was when that first person on the crime scene was dusting everything for fingerprints. Fingerprint experts are the noisiest. You can show them the same set of prints on 2 different days, and they will say on one day, the fingerprints belong to this person, and on the next day they belong to somebody else. Of course, at my age, I don't have any fingerprints. I don't know what that means exactly, but I thought, I could go around committing crimes and nobody could try. Well, now I know the fingerprint examiners are no good anyway. So ignore all those detective novels where they come in and look at the fingerprints because they are the same kind of experts who are just as noisy as everybody else. And of course, clinical diagnosis all over the map and mental illness, plenty of examples. So it's because we're human, because we react to the things that happen to us. We have good days, we have bad days. I love this one. A study of judges in Louisiana gave harsher sentences to kids, especially black kids, the week after LSU college football team lost a game. So already stereotyping is deep in there, but now you throw in this randomness, this noise of the LSU college football game, and it changes the decision they make as a judge, which is going to impact the life of a child who is in trouble. This is a serious problem. France and the US found judges were more lenient when the defendant was having a birthday. Go figure. All right, what can we do? Well, you already know. First, be aware. That won't help. Awareness gets you nothing. But it's a requirement. If you're not aware, then you won't do anything else. So be aware that you're noisy and biased. And then start looking at your decisions. How noisy do they seem to be? Do you see any signs of noise or bias? And then remember, if you're going to talk about a simple algorithm, that takes a fair amount of work and some real experiments. So don't just get rid of your system one and say, no, this is too much work. So that's also important. So after the simple algorithm, the most important technique, and it's something I've believed in for a long time, and I've been looking for a way to work this into a presentation, is called a pre-mortem. So in addition to asking for the slides, if you can't find any of the cited papers, I'll be happy to send them to you. This was created by Gary Klein. Now, everybody knows what a post-mortem is. I mean, that's no longer politically correct. We say retrospective now, thanks to Norm Kurth, and I'm a believer in that. But the post-mortem is something you do after the fact. The patient is dead. There's nothing you can do to help this guy. Too late. So a pre-mortem is done before. So you gather the people who are involved in whatever it is, and then you say to them, let's pretend that this thing that we're about to decide to do is a complete and utter failure. Oh my, that's a little depressing. Okay, now, why would that have happened? What are some reasons why the project would have failed, or if we decide to buy a new testing tool, why it didn't work out for us, or if we decide to hire this person and that person turned out to be more? What are some things that caused this utter failure? And there's something about the way your brain works that assuming, and that's part of it, the very first step is to assume failure. Once you've assumed failure, and now explaining that comes up with more useful information than justifying or arguing for or against a particular decision. Your brain just does a better job. It's called prospective hindsight. Assume the failure and now try to explain it. So in the decision-making process, get rid of everything you're doing now and instead hold a pre-mortem. The other thing you can do is you can measure it in your own organization. Hand some real case over to a bunch of people and ask them to give you an evaluation. So if this were a software development organization, I would say, all right, here's a team. I would like an estimate on this particular project. You don't have to know what the actual is. What you're looking for is whether this team and that team and this team, whether they're going to give you something that's reasonably close together. If not, if one team is telling you that project A is going to take 2 weeks and another team says the very same project is going to take a month and a half and another one says 3 years, you've got a lot of noise. So that's called a noise audit. So in Kahneman's example, they went into an insurance organization and they gave a case to a group of auditors. Before they went in, the executives said, well, we know they're not going to be exactly the same. They said the difference might be 10%. And when they actually ran it, what they found was, oh no, it's more like 44%. And that means time and money. So if there's noise in your organization, one thing you can do is do a noise audit, see whether that's actually a problem. And it won't work unless people are open to negative results, if they will hear bad news and then do something about it. So the absolute worst and the most studied of all the organizational practices is hiring. There is so much evidence that what people do when they bring in someone as a possible hire, that it does not work. It's exactly like our decision-making process. We bring somebody in, and what do? Well, we put them in a room with either a whole team or an individual, and they talk about, well, hey, tell us about your hobbies. What's your biggest fault? What's your biggest asset? Why did you choose this company? So we feel that by having these inane, meaningless conversations, that somehow we are in touch with their innermost being. And we can judge them. We know whether this is a good guy or not. It's an illusion. You have no ability to look into the soul of another person, and after 20 minutes of conversation about hobbies and how many children do you have, to make a judgment call on whether this person will be a successful employee or not. So give it up, people! I don't think I'm convincing anybody. I don't know why I have that feeling. So it's been studied, and there is a better way. It's called a structured interview. You decide ahead of time. This is a little bit like the algorithm. You decide ahead of time, what do you want? We want somebody who can do A and B and C. All right, well, how shall we evaluate A, B, and C? Well, on a scale of 1 to 5, let's say 1 means this, and a 2 means this. All right, and now we will have a collection of independent interviewers who will go in not with the idea of finding out whether or not they're Cubs fans, but whether or not they rate a 1 or a 2 or a 3 on A or B or C. And when they leave that room, that's exactly what they will have. This candidate got a 2 for an A and a 3 for the B and a 1 for the C. And that's my rating. And all of the other interviewers will have the same kind of results. And they will not have shared or talked to one another. They will hand those over to an independent facilitator who is not an interviewer, who will look at those results and see, first of all, where are all the ones? Okay, if everybody agrees that this person is a 1, well, hire. Oh no, here's a candidate where everybody agrees, no, this candidate is kind of a 4 or a 5. All right, no. Now you do need to get together and use a little intuition, a little discussion around the people in the middle. I thought it was a 1, but Fred over here thought, no, I thought it was a 5, and so we need to have a discussion about that. The evidence is clear. Structured interviews work. Nothing is 100%, of course, but this is the way to do it. Get rid of those 30 minutes of wasted time talking to people about whether or not they play poker on Friday night. And this is how Google does it. Laszlo Bock wrote a great book called Work Rules, and he's got a very clear outline of the structured interview process. We know our estimates are bad. There's one study that was done where they said, here's a project, and they knew how long it took. The actual project took 2,400 hours. The original estimate was 1,240. Wow. Wow. So they gave this to a series of other people who said, well, we want to hear your estimates. And here were the 5 results they got. 1,100 hours, 1,500 hours, 1,550, 1,339, and 2,250. Only one of those was close to the actual number, and all the others were optimistic. Is that a problem in your organization? Nobody's saying anything. Oh. The problem with software estimates is that we look to the past. And if you're doing innovative, new things, then everything you do is based on something that you're not going to ever do again. And I don't know about, I do have a PhD in computer science. I did have to take a course in all those estimation models. And the evidence, my friends, is that none of them work. That's as in zero. They are useless. You can quote me on that. Kokomo model, they're all bad. They're all bad. Because they're based on past data, and you fudged most of that past data anyway. I don't know how many companies I have consulted with where I say, well, where's your data? And you look at it, and you know they didn't do that. You know they made it up. And yet they claim, oh, yes, we have all this data. And we will use it to improve our estimates. Such a pile of... The Agile approach says, the question is, what do you want? So to your customer, what do you want? And they will say, well, I really want all of this, but really we care about, and so do that first. Then do they like it? Is there anything else they want? And if you have time left over, do it. If not, stop. Estimates are for the birds. Could be another talk, sorry. I digress. But it's a waste of time. You figured out that I'm 81. So how long have I been working? A long time, and I'm still working. I have never seen this estimation process work. The only reason we still do it is somebody wants a number. Well, make it up. That's what you're doing anyway. Make it up and give them the number, and then everybody's happy, and then just go through this process. Just saying. Kahneman recommends something called the inside view. If you do have to come up with an estimate, we are all stuck in the inside. We look at the details. Well, we have these 3 modules, and we've got 4 people who can work on the first module, and then we know we're going to have to go. That's nonsense. He says, you should be looking at the outside. Stand away from that and ask, has anybody done anything like this? Another company, perhaps? Another team? Another part of the company? How long did it take them? And now start with that. And then say, but they had 4 people and we have 3. Okay, you make a little adjustment. Okay, theirs was distributed, ours is not. Make a little adjustment. They were using that programming language, we're using, okay, make a little adjustment. But don't waste a lot of time on it. Don't get buried in the detail because the details will change anyway. Again, if you can find that paper, I'll be happy to send it to you. That outside view is called a baseline. That baselines are available. They're out there. Share those. That's where you start. Not with the details, but the baseline. Okay, the good news is if you do reduce the noise, you will also reduce bias. There's an ongoing project now on forecasting that shows very clearly where these things come together. That we know now, because we can measure it, that we know there are elements in decision-making. You need more information. That's about 25%. Yes, there's a problem with bias. That's typically another 25%. But the new result, what came out in noise, and a whole host of papers that have just been published is 50% of the error that people make in decision making is due to noise. 50%. So not only are there things you can do about it, but it will have the biggest impact. I don't have a copy of this book because I read it so long ago, but it's excellent. I recommend it. Let's close by realizing you are now aware. I pronounce you aware. You are all aware. But remember, that won't do anything. You think you're going to go out, and because you're so aware that you're going to make some big changes. Well, okay, fine if you do the changes, but it will be because of the awareness, not because being aware made you a better decision maker. Just like being aware of those biases, that did not help. And finally, I hope, don't get rid of people. That's not what we're saying. There's a time and a place, but it's at the end, like the hiring process. After everybody's had their independent input, then, okay, we can have a little discussion. Okay, then we can have some gut feelings, but don't ever start with it. Intuition is the place where you come together. It's not the point of departure. So there's a little summary. Watch out. Do a noise audit. Think about a simple algorithm. Structured interview. Pre-mortems. Uh-oh. Keep learning. That's good. I like that. Thanks so much for listening. I appreciate it.